Hello, in today's practical, I'm going to be demonstrating correlation and simple regression in Stata, as well as how to interpret the output. And in doing so, we're going to go through the 8 steps of the research process for simple regression. Now, when I refer to steps, I'm not necessarily talking about the steps outlined in the practical worksheet, but rather the 8 steps of conducting research. And we're going to be going through these steps pretty much every practical from here on out. Now, the first step of the research process is just understanding your hypotheses or your questions. And this information will generally be laid out in the background information for all of your practicals. So it's really important that you read through those before you just move into Stata. Right? And we can see down here what research question we're trying to answer. And here we're going to be examining whether judges' scores can be predicted individually from research, building, and innovation. Right, so here, research is the number of hours that a student took in completing the research for the project. Building is the number of hours they spent building. And innovation is how innovative the idea was. And those three are going to be our independent variables because we want to predict judges' scores from those three variables of interest. Can we predict judge ratings from these three from these three variables individually? Right, and there are a couple of key words for us to look for in determining what type of analysis is most appropriate. The main one being here predicted. This is telling us that we want our analysis to predict judge score from our independent variables, and that's where regression is going to come in. If a research question simply asks, what is the relationship between two variables, then we can assume correlation is most appropriate. But when we want to predict actual outcome, that's when we need to consider regression. Right, and then next, individually is another key term. This is telling us we're going to actually have to perform 3 separate regressions. So we actually have 3 different research questions for this practical. Okay. Step 2 is identifying our variables. And in this data set, we have 5 variables. The first one being project, that's similar to participant ID number. That's just an identifier. Research, again, is number of hours spent researching the topic, and this is one of our independent variables. Build is number of hours spent building the project, and again, that's one of our independent variables of interest. And finally, how innovative is the project idea? And this is on a scale from 1 to 4. And this is our final independent variable. Right, and then our dependent variable is ratings, overall judges score out of 50 points. Now, importantly, all of our variables of interest here are numeric. And that's and that means regression will be really well suited for these data. Regression works really well with numeric variables. Right? And then the third step of the research process is understanding our sampling population. And these data come from a group of year 6 students who completed a research project and competed in the state finals all across New South Wales. But our unit of analysis here isn't people or students, but rather the project itself. And now we can go into Stata to assess our univariate descriptive statistics. And the first thing we have to do, of course, is import our data set. We're using the same series of commands that we did last week. So web use set, the same link, but this time we want to import the science fair data set. When we run that command, we can see that we have our variables populated here. Right, we're going to be using the same series of commands that we did last week. All right, so first the summarize command will give us our descriptive statistics, such as measures of central tendency and skewness and kurtosis. Remember that comma detail at the end is really important because that tells data to give us skewness and kurtosis, as well as the range. When we run that command, we now have 4 tables, 1 for each variable. I'm not going to go through each in detail, but I do just want to quickly talk about at least one of our independent variables and our dependent variable. So our first table here gives us information about hours spent researching the topic. Okay, we can see the shortest amount of time was 6.1, and the longest amount of time was 11 hours. The average amount of time was 8.36, with a standard deviation of 1.29. And we can see our average value is very close to the median, suggesting we have good central tendency. Next, our skewness statistic of 0.11. This suggests a slightly positive skew, as anything greater than 0 would be positive, but it's definitely well within the range of acceptable values. So anything between -1, -1 and +1 would be considered acceptable, but we should confirm that with a frequency distribution. And our kurtosis statistic of 2.17, that suggests a fairly platycritic distribution. Again, it's within that acceptable range, but I would certainly call that platycritic. But first, let's check out our dependent variable, judges' ratings. All right, so this final table here is our judges' ratings, the dependent variable. And we can see the smallest value or the lowest rating is 9.7, and the highest rating was 65. The average score was 31.73, and that is relatively close to our median of 34.9. As with hours spent researching, it looks like our skewness statistic suggests a slightly positive skew. 0.27 would be considered slightly positive, and our kurtosis statistic of 2.43 would suggest a slightly platycritic distribution. So all of this should start to become second nature to you. Let's go ahead and confirm these statistics with a frequency distribution. Right. You could simply type out histogram research for the frequency distribution for research, but if you wanted to specify the number of bins, you can include the command comma frequency bin, and that bin number is just telling Stata how many sections you should break up the distribution into. This doesn't actually change anything about the distribution, it's just purely visual. Right, and when we run that command, we can see there is central tendency, perhaps a very slight positive skew, and definitely a lot of weight in the tails, which would be a platycritic distribution. So that seems to confirm the statistics from our summarize command. All right, and let's take a look at one more distribution. Let's check out the independent variable innovative. Okay, again, I'm going to tell Stata to break it up into 8 bins. Right, and from this, we do see that the distribution is a little bit wonky. There certainly is central tendency. I don't think these peaks here are extreme enough to be considered multimodal, so I would still consider this bimodal. But the tails, again, definitely have a lot of weight, so I would also say that this is platycritic. Now, the important thing to remember with regression is that the assumptions of regression are not about the raw variables themselves, but rather the distribution of the residuals. So we're going to talk about that after we actually fit the model. But even if we have some strange looking distributions here, even if they're not perfectly normal, we can still go ahead and run the regression. We just have to remember to be careful about examining the residuals. Right, and the last thing we're going to do is confirm the normality of our dependent variable with a Shapiro-Wilk test. The command here is swilk, swilk, ratings. Remember, our dependent variable is ratings. Now, the important statistic here is our p-value. And here we have a p of 0.40. Now, if you think about the null hypothesis for the Shapiro-Wilk, the null hypothesis states that the data are normally distributed. Therefore, we want to fail to reject the null hypothesis. If our p is less than 0.05, That means we would actually have to reject this null and conclude that the data are not normal. With a p greater than 0.05, that means we confirm the null hypothesis and can conclude that the data are normally distributed. All right, so it looks like our dependent variable is good. And now we can move on to our bivariate statistics.